you're going to see a lot of similar things from what we did in 7.2 when we were doing our Z tests for hypothesis testing. The difference now is we don't know the population standard deviation. We're only going to have a sample standard deviation. And if you remember talking about those with our confidence intervals before, if we know the population, we use Z. If we only know a sample, that's when we use T. So today you're going to need your T chart. So that's what you want to have kind of handy and in front of you. Okay, the first thing that we're going to talk about, practice, is how to find critical values of T. So you're going to know your level of significance at the beginning. Remember, with T's, we have degrees of freedom, which is always one less than our N value, so you're going to need that piece of information. Once you know your level of significance and degrees of freedom, you should see at the top of your T distribution table, there's 3 options across the top. There's, I think, the confidence level, but then 1 tail and 2 tail is what we're going to focus on. Okay, so you're going to use the 1 tail option if it's either just in the left tail or just in the right tail for your test. You're going to use 2 tail if it's a 2 tail test. If it's a left tail test, you're going to use that number and that level of significance and that degrees of freedom to find the value in the middle. And then the left tail test, because it's a critical value on the left side, you're just going to put a negative in front of the number that you find on the chart. If it's a right tail test, you're going to use a positive value because it's on the right side. And if it's a 2 tail test, we're just going to put a plus or minus in front of the number we find on our chart. So let's practice that. Okay, so the first one we want to find is a critical value, T sub 0 or T null, for a left tail test with a level of significance of 0.05 and then a sample size of 21. So if my sample size, my N is 21, what's my degrees of freedom? 20, always 1 less than that. Okay, so it's left tail, which is 1 tail. All right, so let's see here. So we're going to go across the top where it says 1 tail, and we're going to look for a level of significance of 0.05. So that'll actually take me into the second column. Then we're going to go down to 20 degrees of freedom, and you should be able to find the number 1.725. And because it's a left tail test, we just put a negative in front of it. Everybody see that number okay on their chart? No? Yes? Okay, so 1 tail. Go over to our level of significance, 0.05, and then put down to the line 20. Okay, let's try another one. Critical value for a right tail test, so we're still looking at 1 tail, with a level of significance of 0.01, N is 17, degrees of freedom is 16. Okay, so I'm in the 4th column now, it looks like. Go down to 16 degrees of freedom, 2.583. And we just leave it as the positive value because it's the right tail test. Last one, critical values for a 2 tail test, level of significance 0.1, N is 26, degrees of freedom therefore is 25. So now we're looking at 2 tail across the top. Go over to 0.1, which will take me to the second column. Go all the way down to 25, and you're going to see 1.708. And because it's a 2 tail test, we're going to have critical values on the left and the right, so we just put a plus or minus in front of that. Any questions calculating critical values? All right, you guys try the 3 on the next slide there real quick. All right, let's check them. Oops, too much. Here we go. Okay, any questions on those? All right, moving on. Okay, so next thing we're going to do, I don't want that just there yet. Let's move that away. Go away. Okay, next thing we're going to do is we're going to use a p-value to do a t-test. So we did p-values with our z-scores. P-values represent areas, and it's really easy to find those areas with a z-score chart. So we did these by hand, and I did show you how to do it with technology also for the z-score chart, but we usually do those by hand. With a t-test, it's a little bit more difficult to find that area. So usually we just use technology to do a p-hypothesis test or a p-value hypothesis test for these. Okay, so very similar to what we did before with the z-scores. Let's go ahead and read through it here. We'll write our hypotheses. It says the Department of Motor Vehicles office claims that the mean wait time is less than 14 minutes. A random sample of 10 people has a mean wait time of 13 minutes with a standard deviation of 3.5 minutes. At a level of significance of 0.1, test the office's claim. All right, so a couple things we always check at the beginning. We have a random sample, check. We also want to make sure our sample size is bigger than 30 or the population is normally distributed, check. Then the next thing we want to get in the habit of now is looking at that standard deviation. If the standard deviation is from a population, we know we use Z's. If a standard deviation is from a sample, which this one it said it came from the sample, it's from a T. And if you're calculating the standard deviation, likely it is a sample. You're given a sample set of information. So if it doesn't tell you one or the other, look at the data that you have that you're calculating it from, and it's likely a sample. Okay, so hypotheses, null and alternative. The claim is that the Department of Motor Vehicles says the mean wait time is less than 14 minutes. So less than 14, because it's strictly less than, it's my alternative, and we're going to label it as the claim. Is that a left tail, right tail, or two tail test? There's a left tail test. Okay, and then your null is going to be that the mean is greater than or equal to 14. Okay, things that we're going to fill in our calculator in a second. So the first thing it needs is the mean value from the null, or the alternative, it's the same thing. That's just our 14 that we're going to fill in there. Our X bar is our sample mean. They gave us that. That was 13. Sometimes you'll have to calculate that on your own. You can always use a spreadsheet or one variable statistics in your calculator. S for sample standard deviation was 3.5. Sample size here was a 10. And then this last one, actually, let me show you. I don't think I have that on there. Maybe. Let me see. Can I slide it over there? There we go. This last one, you've got 3 different options, which it's a little confusing because they write it as the null, but pretty much you just want to make sure that this symbol matches whatever your alternative hypothesis is. So the first one, if you want to label it, we did this when we did the z-test also. The first one is your two-tail test. You're going to pick the one that says not equal to. The second one is your left tail test, which is what we want for this one. And then the last one is a right tail test. So based on your tail, you're picking one of those 3 options. Okay. And then you hit calculate. All right. So now how we get to this, just a reminder if you don't remember, we hit stat. We go over to tests. And then you have to pick between Z and T. We know we're using T. So number 2, and then you're just going to put all this information in there. So 14, 13, 3.5, 10, and my less than option, doesn't matter what color you have there, calculate. And then it should spit out something that looks like that. So it does tell you your critical value of T. So if you had to answer that in Math Excel, that's that line right there. That's our little T sub 0 it's giving us. Gives us a bunch of decimal places too, which is nice, a little more accurate than our charts. But really what we care about in order to perform the hypothesis test is that P value. Okay, so P right now is to 3 decimal places 0.195 about. And alpha in this problem we were told is 0.10. So the same rules are going to apply as what we talked about before. If P is less than alpha, we're going to reject. If P is greater than alpha, we do not reject. In this case, P is greater than alpha, so we do not reject our null hypothesis. And then you can summarize that. So in this case, we would say there is not enough evidence to support the motor vehicle's claim that the mean is less than 14 minutes for their wait time. Okay. Same summary as we practiced in the past. Everybody able to get that number okay in their calculator? All right, the next 2 on your paper then are for you to try with technology. So calculate the p-value with technology And then from there, decide if you're going to reject or not reject the null and summarize. Okay. That's what I got for these. You can see what my calculator output looks like. All right, so if it says use technology, you're going to use the same method with p-values, either use z or t-test, depending on which standard deviation you have. If it says to do it by hand, you guys are likely going to be using the rejection regions and the critical regions, which we'll do that part actually tomorrow for t-test. That's that lesson. Okay. Any questions on either of these with the calculator? See, hope those still right, and I'll give you another second. Then we just got one more quick problem, and we're done. Okay. Last problem kind of leads into tomorrow. So we practiced already finding those critical values of t, either on the left side, right side, or on both sides if it's a two-tail test. Those tomorrow are going to create those rejection regions like we practiced with the z-test yesterday. So we're just going to practice here deciding if we're going to reject or not reject based on where our critical regions are located. So for the first one on the left side there, we have a critical value. It looks like it's a right tail test at 1.402. So then let's say you calculated your own test statistic t, it was 1.4. Is 1.4 in our rejection region? It is not in our rejection region. So the decision we would make is what? Do not reject. Okay, what about 1.42? What decision would you make? Reject? Negative 1.402? What would we decide? Do not reject. Not in our rejection region. Okay, if it's a two-tail test, you just got to make sure you look on both sides. What if my t-value is negative 1.755? What would your decision be? Reject. What about negative 1.585? Do not reject. What about the last one? Reject. Okay, that's it. All right, so we'll do a t-test by hand with critical values tomorrow, and then that'll wrap up 7.3. 7.2 Math XLs are due tonight if you have not finished those yet. 7.3 is just a one-part Math XL, and it's due on Thursday is your next deadline. Okay, so we got two more lessons. We're going to finish up 7.3 tomorrow. We're going to do 7.4 on Thursday, and that's it. Cell phone lotto winner is number 1. Okay. Rest of the period is yours to work on your homework.